Ladies and gentlemen, we ask that you please take your seats at this time as the program will begin momentarily.
While in experimental research, we manipulate variables, also known as the independent variable, and this manipulation can either be done between groups, known as the independent design, or within the same group, known as the repeated measure design. For experimental research where we manipulate variables between groups, and when there are two groups, we can apply a t-test.
This is a demonstration on the use of Jamovi to conduct an independent samples t-test. We'll first open a dataset that comes with Jamovi in the data library. Click on the menu, Open Data Library, and select the bugs dataset. This data comes from an experiment where participants were asked to rate their hostility towards insects that were categorized by how disgusting and how frightening they are. As a good practice, we should first inspect the data. For now, we assume the data have been inspected and we are interested in 5 of the columns. We'll take gender that has been coded as female and male as the independent variable, and the rating of hostility across the 4 categories as the dependent variables. LDLF stands for low disgusting, low frightening, LDHF, low disgusting, high frightening, HDLF, high disgusting, low frightening, HDHF, high disgusting, and high frightening. For the purpose of this demonstration, the research question is whether females and males differ in their rating of hostility across the 4 categories of insect. And the null hypothesis is that there is no difference in the rating of hostility across the 4 categories of insect between females and males. To perform the independent sample t-test, click on t-test under the Analysis and Independent Samples t-test. Then select the 4 dependent variables, move it to the right-hand side. The independent variable gender will be selected as the grouping variable. Select the assumption checks for homogeneity and normality, as well as additional statistics such as mean difference, effect size with 95% confidence interval, descriptives, and descriptive plots. Before we look at the results from the t-test table, let's look at whether the data meets the assumptions. Based on Shapiro-Wilks test, we need to check that the p-value is more than or equal to 0.05. And LDLF meets this assumption, but not LDHF, HDLF, and HDHF. With p-value less than 0.05, this suggests that the data is not normally distributed. And for the homogeneity of variances, we are given the Levene's test. Over here, the p-value should also be more than 0.05. And this is indeed the case, which means that the data all meets the assumption of homogeneity of variances. Looking at the descriptive table, we can look at the mean rating of hostility and observe that the female's mean rating of hostility is slightly higher than the male for LDLF, LDHF, as well as HDHF. However, for HDLF, the mean rating of hostility for male is slightly higher than female, but we can't tell whether these differences are significant. Next, we can look at the plots to get a clue on whether these differences are significant. As a general rule of thumb, if there is an overlap of 95% confidence interval, there is no significant differences between the 2 groups. The same for HD, LDHF, HDLF, as well as HDHF. Let's return to the results table at the top. The parametric student's t-test with p more than 0.05 suggests that there is no significant differences between male and female on the ratings across the 4 categories of insect. And that means that we cannot reject the null hypothesis. Given that assumption of normality has been violated in 3 of the categories of insect, we can also select the Mann-Whitney U test, which is a non-parametric version of the t-test. Looking at the p-value of the Mann-Whitney U test, It seems to also suggest that there are no significant differences between males and females for LDLF, LDHF, and HDLF. But for HDHF, there seems to be a significant differences between males and females.